Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we are wrapping up quadrilaterals. We've learned a lot about quadrilaterals, and hopefully by now you understand that parallelograms are the root of all quadrilaterals, okay? Except for trapezoids, of course, and kites. But parallelograms are pretty much the root of all special quadrilaterals. And today we're going to prove how figures are special quadrilaterals. And these special quadrilaterals are all based on parallelograms. So proving that a quadrilateral is a rectangle. Okay, we're going to first talk about rectangles. And you can prove that a quadrilateral, EFGH, which is down here, EFGH, okay, is a rectangle by first showing that the quadrilateral is a parallelogram, and then using either of the following methods to complete the proof. So, number one, if it is a parallelogram, okay, if a parallelogram contains at least one right angle, then it is a rectangle. So, we learned yesterday that if they give you a figure and they tell you any of the 5 following things, opposite sides are parallel, opposite sides are congruent, the diagonals bisect each other, okay? That's a parallelogram. If any of those things occur, opposite sides are parallel, opposite sides are congruent, at least one pair of opposite sides are both parallel and congruent, and if diagonals bisect each other, that's it, right? That's a parallelogram. So if you have any of those 5 things that we just marked here on this quadrilateral, any of those 5, that means it's a parallelogram. And if it's a parallelogram and a parallelogram has at least one right angle, then it's a rectangle. Done. Period. If the diagonals of a parallelogram are congruent, then it's a rectangle. So at this point, not only do they bisect each other because it's a parallelogram, but all of the bisections are congruent. That's why I added another tick mark on those diagonals. So the diagonals are congruent. Okay, the diagonals of a parallelogram are congruent, then it is a rectangle. And the third way to prove that a parallelogram is a rectangle is if all 4 angles of the quadrilateral are right angles. So it's 6 to 1, half dozen to the other. If you have at least one right angle, it's a rectangle. And if you have all 4 angles are right angles, it's also a rectangle. And if a parallelogram has congruent diagonals, then it is a rectangle. So again, if a parallelogram has equal or congruent diagonals, it's a rectangle. And if a parallelogram has 4 right angles, it is a rectangle. Let's pause for a second. Okay, so let us continue there, gentlemen. Sorry about that interruption. Okay, proving that a quadrilateral is a kite. All right. Now, a kite is not based on a parallelogram. A kite is not based on a parallelogram. A kite is not based on a parallelogram. A quadrilateral is a kite, though, if 2 disjoint pairs of consecutive sides of a quadrilateral are congruent. Then it is a kite. So we've talked about this before. If this disjoint pair and this disjoint pair are congruent, then it is a kite. And also, if one of the diagonals of a quadrilateral is perpendicular bisector of the other diagonal, then it is a kite. Okay? So basically what's happening here if TK is the perpendicular bisector of IE, or is it F? IE. Of IE, and that means that it's a perpendicular bisector, so it cuts these two into perfect halves, and it creates a 90, then that is a kite. Okay? So a kite is a quadrilateral in which one diagonal is the perpendicular bisector of the other diagonal, and or two disjoint pairs of consecutive sides are congruent. Does that make sense? So a kite is one of the special quadrilaterals that is not based on a parallelogram. Okay? Not based on a parallelogram. May I continue, brothers? Okay. Proving that a quadrilateral is a rhombus. Okay. A rhombus is based on a parallelogram. A rhombus is based on a parallelogram. So to prove that a quadrilateral is a rhombus, you may first show that it is a parallelogram. Not may, you must actually show that it is a parallelogram. And then apply either of the following methods. So, number one, if a parallelogram contains a pair of, a pair of consecutive sides that are congruent, then it is a rhombus. Let me explain that. Okay, we're going to go over the parallelogram proofs again. So we have to prove that it's a parallelogram. How do we prove that it's a parallelogram? We can prove that it's a parallelogram if they tell you that opposite sides are congruent, if opposite sides are parallel, or if they just tell you one pair of opposite sides are both parallel and congruent, if the diagonals bisect each other, and of course I've been missing one, if opposite angles are congruent, right? If opposite angles are congruent, I apologize, I forgot about that one. All right? Then it's a parallelogram. So if I tell you have this parallelogram, but I tell you that consecutive sides are congruent, consecutive sides are the following. If I tell you this is a parallelogram, but this guy and this guy are congruent, those are consecutive sides. Or if I tell you this side and this side are congruent, those are consecutive sides. Or if I tell you this side and this side are congruent, those are consecutive sides. So if I have a parallelogram and consecutive sides are congruent, then it is a rhombus. And let's think about that. A rhombus has all equal sides. Well, if a parallelogram has consecutive sides that are congruent, aren't opposite sides congruent in a parallelogram? So if this side here is congruent to this side, and opposite sides are congruent, that means that this side is also congruent to this side, and this side is also congruent to this side because of transitive property, so then all sides are congruent. So if they give you a parallelogram and they say that consecutive sides are congruent, then it is a rhombus. If either diagonal of a parallelogram bisects two angles of the parallelogram, then it is a rhombus. So I'm going to erase this for a second just to have a clearer picture. Okay? We know the diagonals of a parallelogram bisect each other. But if I tell you, you have a parallelogram and the diagonals bisect two angles of the parallelogram, then it is a rhombus. Because by definition, the diagonals of a rhombus bisect the angles. Yes, sir? We're going to get to squares in a second. Okay? Give me 1 second. But yes, the question was, are all squares rhombuses? Yes. But are all rhombuses squares? No. Yes, sir. Okay. Squares are rectangles? Yes. But are rectangles squares? No. Good man. Good man. So we have, if If a parallelogram contains a pair of consecutive sides that are congruent, it's a rhombus. If the diagonals of a parallelogram bisect two angles of the parallelogram, then it is a rhombus. And if the diagonals of a quadrilateral, well, I should have said parallelogram, but okay. If the diagonals of a parallelogram, really, bless you, are perpendicular bisectors of each other, then it is a rhombus. So, does that mean that the diagonals of a rhombus are congruent? Guys, it's a question. No, very good. Whoever said yes, think about it. It's a parallelogram. So that means that the diagonals bisect each other. Okay? But it's not a rectangle. A rectangle has diagonals that are congruent. A rhombus has diagonals that are perpendicular bisectors of each other. So it is perpendicular bisectors of each other. That's what creates a rhombus. So again, if a parallelogram contains a pair of consecutive sides that are congruent, it's a rhombus. If either diagonal of a parallelogram bisect two angles of the parallelogram, then it is a rhombus. And if the diagonals of a quadrilateral are perpendicular bisectors of each other, then it is a rhombus. Does that make sense, gentlemen? All right. Proving that a quadrilateral is a square. Okay. You can prove that a quadrilateral is a square if a quadrilateral is both a rectangle and a rhombus. So what does that mean? Okay, it's a rectangle. So that means it's a parallelogram that has all equal angles, which are 90, plus it's a parallelogram that has diagonals that are congruent, but it's also a rhombus, so that means the diagonals are perpendicular bisectors of each other. So a square has opposite sides, all sides are congruent because it's a rhombus. It's a rectangle, so that means that all of the angles are 90. It's a rhombus, so that means that the diagonals are perpendicular bisectors of each other, but it's a rectangle. So that means that the diagonals are congruent. And it's a rectangle, so that means opposite sides are parallel. So a rectangle, okay, is a rhombus. A square is a rhombus. A square is a parallelogram. A square is a rectangle. Square is basically the mother of them all. But is a parallelogram a square? Is a rectangle a square? Is a rhombus a square? No. So a square is a rhombus and a rectangle. So basically, really, if you think about it, since a rhombus and a rectangle are parallelograms, a square is a parallelogram, a rectangle, and a rhombus. So that means opposite sides are congruent. All sides are congruent. Opposite sides are parallel. All the angles are 90. The diagonals bisect the angles. And the diagonals are congruent and they're perpendicular bisectors of each other. Yes, sir?
Those opposites that you asked, for example, like the rectangle squares, those would be sometimes.
Is a rectangle a square? That would be sometimes. A rectangle is a square sometimes. Yeah, it depends. But a square is always a rectangle. Does that make sense?
Yeah.
Thank you, my brother. May I continue, gentlemen? All right, let's do it. Proving that a trapezoid is isosceles. By definition, a trapezoid is a quadrilateral where you have exactly one pair of opposite sides that are parallel. It is an isosceles trapezoid if the non-parallel sides of the trapezoids are congruent. So that means, in other words, if the legs are congruent. So if it's a trapezoid, you have one pair of opposite sides that are parallel. If it's an isosceles trapezoid, you have one pair of opposite sides that are parallel, and the legs, the non-parallel sides, are congruent, as I just marked on the figure. Also, if the lower or the upper base angles of the trapezoids are congruent, then it is an isosceles trapezoid. So basically, if I tell you that the lower base angles are congruent, it's an isosceles trapezoid. If I tell you the upper base angles are congruent, then it's a trapezoid. Or if I tell you the diagonal of a trapezoid are congruent, then it is an isosceles. So similar to a rectangle, the diagonals of a trapezoid are congruent. So AC would be congruent to DB. So if I told you, name all of the figures where the diagonals are congruent, you'd have an isosceles trapezoid, you'd have a rectangle, and you'd have a square. And that's it. If I told you which figures have diagonals that bisect each other, you'd have a parallelogram, you'd have a rectangle, you'd have a rhombus, you'd have a square, but not a trapezoid. And just for giggles, let's see if we're thinking. What do we know about the sum of angle A and angle B? They're supplementary. Very good. Why? Because of same side interior angles. Since AD is parallel to BC, that means that angle A plus angle B must equal 180, same side interior angles. Does this make sense, gentlemen? Okay, I know it's a lot, but hopefully it's congealing. Hopefully it's coming together for you. May I continue, or are there any other questions? How can I help you? Yes, sir.
The angles they're not bisected in the trapezoid.
The angles are not bisected. No, I did not say that. They are not. The only diagonals that bisect the angles of a quadrilateral are that of a rhombus and of a square. Yes, sir. Thank you, my brother. Okay, let's get to it. What is the most descriptive name for the quadrilateral ABCD with vertices ABCD being given? Now, a lot of people will look at that and they'll just shoot out names. Oh, it looks like this. It looks like that. It looks like the other. Looking like things means nothing in geometry, guys. I'm sorry. You have to prove. Now, let's see what we can prove. What do we know about the slopes of parallel lines?
They're negative reciprocals.
They're equal. Very good. Okay. And what do we know about the slopes of perpendicular lines? They're negative reciprocals. So let's think about this. Let's first see if the opposite sides are parallel. Because if opposite sides are parallel, what is it automatically? A parallelogram. Very good. And then we're going to check to see if the consecutive sides are 90 degrees. If the consecutive sides are 90 degrees, then what kind of a parallelogram is it? No, a rectangle. Then we can use the distance formula to see if opposite sides are congruent. Then we can see if all sides are congruent. Okay? And then it can maybe be a square or a rectangle or just a parallelogram. So first, let's check the slopes of opposite sides. Okay? Let's check the slopes of opposite sides. So let's compare the slope. Let me change the color there. Let me change the color here to red. Let's first compare the slope of AB and CD. Now, instead of using math, let's use logic. Let's go down from left to right. I'm going down 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to the right. I'm running 1, 2, 3, 4, 5, 6. Okay? So down 8 over 6. Let's go from C to D. 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6. So far, CD and AB are parallel, correct? You guys with me there? Okay. Now, I'm going to erase the math here just to not confuse everything. We've already proven, though, that CD is parallel to AB. Now, let's check out BC and AD. Left to right, I'm going up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So up 8 over 12. Let's go A to D. 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? You with me there, guys? So that means that opposite sides are parallel, correct? Now, think about the right triangle we just created. If that's 8, that's 12. Isn't CB also congruent to AD? Because of Pythagorean theorem, right? Hello? Guys, yeah? Okay, so opposite sides here are both parallel and congruent. So we know for sure this is a parallelogram. You with me there? Okay, now, let me go back in blue, and I guess I should have left this. This was negative 8 over 6, correct? And this was negative 8 over 6. Okay. So, let's look at that slope of CB, which is 8/12. And let's look at the slope of AB, which is negative 8/6. Are those guys negative reciprocals of each other? So is angle CBA a right angle? So that means immediately it's not a rectangle and it's not a square. Are all sides equal here? Okay, someone said yes, and that's no, it's not. They're not equal. So therefore it's not a rhombus. So what's the best quadrilateral here? Parallelogram. Does this make sense, guys? This is the kind of stuff you will see on the SAT. You won't see proofs, but you will see stuff like this. Does this make sense, gentlemen? So I had to prove to see if opposite sides were congruent and if they were parallel. Then I had to check the slopes of the sides to see if I had a 90. You with me? Yes, sir.
They would have to give you all the vertices.
They'd have to give you the vertices, or you could find the vertices if they give you a graph. Okay? Thank you, my brother. Yes, sir. Does that make sense, though, guys? Okay. Let us continue. Okay, your favorite part. Proofs. They tell you right from the beginning here that ABCD is a parallelogram and BD bisects angle ADC and ABC. So that should give you a hint right off the bat. If BD bisects ADC and ABC, we're looking at potentially a rhombus or a square. I want to prove that ABCD is a rhombus, though. So, first, ABCD is a parallelogram. That's given. So right off the bat, if it's a parallelogram, we know opposite sides are parallel, opposite sides are congruent, diagonals bisect each other, opposite angles are congruent. Okay, we know all of that. Number two, since it is a parallelogram, I know for sure that angle ADC is congruent to angle ABC because of definition of parallelogram. If opposite angles of a parallelogram are congruent, you could put definition of parallelogram. Since we were given that BD bisects ADC, okay, that's given. That means that these two guys are bisected. And that's given. You with me here, boys? Okay. Then I know that ABD is congruent to ADB because of division property. I had told you before that angle D is congruent to, ADC is congruent to ABC because definition of parallelogram. If I tell you that BD bisects ADC and ABC, that means it cuts it in half. So that means that ABD, which I'll mark in red, is congruent to ADB because of division property. If you cut something in, if you cut a congruent angle in half, then the halves are congruent. Yes, sir.
That's the double bisector, right? Because it's the two angles.
A double bisector. No, BD is bisecting ADC and ABC.
The only confused multiplication and division is one that has a double bisector.
Yes, because it did bisect two angles. That's exactly correct. Good man. So it is a double bisector. Good man. Good man. Proud of you. Now, I know that AB is congruent to AD. AB is congruent to AD. Why? Definition of an isosceles triangle. Very good. If angles, then sides. Very proud of you, son. And then, think about it. If we have a parallelogram, which we do, with consecutive sides being congruent, what kind of a quadrilateral is it? It's a rhombus. If a parallelogram contains a consecutive pair of congruent sides, then it is a rhombus. Does that make sense, gentlemen? Are you sure, my brothers? It should be clicking by now. Parallelogram was the base for this. But we had to throw in some if angles then sides. That was really good. I'm really proud of you. Does that make sense, boys? Okay. Good stuff. Next. I have here that GJMO is a parallelogram. So GJMO, did I not? Oh, I didn't put the figure? Well, that's unacceptable. Hold on right quick. Let me do the figure here. Sorry about that. It's always nice to have the figure, as we have seen through our proofs. Okay. So I am told that GJMO is a parallelogram. So that means this guy. GJMO is the parallelogram. OH is perpendicular to GK, and MK is an altitude of triangle MKJ. Those are my givens. So let's prove this sucker. Okay. Number one, GJMO is a parallelogram. Again, I'll highlight it here for you. I'll do it in red. So GJMO is a parallelogram. I know I'm a broken record, but that means opposite sides are congruent and parallel. That means opposite angles are congruent. That means that the diagonals bisect each other. Okay, keep that in mind. Next, since it's a parallelogram, I know that OH, well, not because of a parallel, that's, whoa, I messed up here. That should not be parallel, that should be perpendicular. My bad, I'm sorry. I made a big error. OH is, bless you, perpendicular to GK. Because, wait a second, hold on. All right, I apologize. I shouldn't second guess myself. I just wrote this wrong. Okay. It is parallel, but it's not OH. It's OM. My bad. OM is parallel to GK. Why? Because opposite sides of a parallelogram are parallel. So this guy is parallel to that. My bad. Now I can go with the given that OH is perpendicular to GK. That's given. So OH is perpendicular to GK. So that means I have two 90s right here. Okay? Bless you. They tell you that MK is an altitude of triangle MKJ. So that means that angle MKJ here is a 90. Okay? So MK is perpendicular to GK. That's definition of an altitude. And then here you got to think clearly here, guys. Look at this angle here, OHG and MKJ. OH must be parallel to MK in this case. Why? Come on, guys. If this guy here and this guy here are both 90, don't I have the F here? And that's not same side interior angles. That's not alternate interior angles. That's not a Z. That's an F. So it'd be corresponding, but they're parallel. So if two coplanar lines are perpendicular to a third line, they are parallel. So we could have done that theorem, or we could have said corresponding. Come on, guys. You got to know this. The underbelly to underbelly. All of this comes into play. From there, now I can say that quadrilateral OHKM is a parallelogram. Definition of parallelogram. We prove that opposite sides are parallel. So that means that OHKM is a parallelogram. Then I know that angle OHK is a right angle. Definition of perpendicular lines. We already proved that that was a right angle. And if I have a parallelogram with one right angle, what kind of a quadrilateral is it? Boom. Definition of rectangle. If a parallelogram contains at least one right angle, then it is a rectangle. Guys, I have noticed that on two proofs already that we've done yesterday and today, when you had the corresponding angles, you guys thought it was same side interior angle, and one of you guys thought it was alternate interior angles. Alternate interior angles, you form a Z. Same side interior angles, you form a U or a C as in cat. And those are not congruent. They have a sum of 180. They're supplementary. But the F is really eluding you guys. Look at it, guys. There's an F here. Underbelly to underbelly. Those are congruent because of corresponding angles. Or it's the parallel postulate. If two lines are perpendicular to a third, then they are parallel to each other. Does this make sense, guys? It's going to be on your final, on your midterm. It's going to be on your final. And it's going to be on your test. And I think we're done. Any questions on this? Yes, sir. Yes. Yes, sir. Okay, I'm going to erase all of this. Thank you for your question and thank you for your honesty. He's wanting to know basically how I got this. Okay? All right. We had proven already that OHG and MKJ were 90 degrees, correct? Okay. Does this not form an F lying down? Isn't this underbelly to underbelly? Yeah. So if those are congruent, that means that OH is parallel to MK. You could have done one of two things here. You could have said corresponding angles. If corresponding angles are congruent, then the lines are parallel. Or you could have said, if two coplanar lines are perpendicular to a third line, then they are parallel. So there's two postulates that would have helped you there. Yes, sir?
You have just said the F postulate.
No, the F postulate doesn't exist. It's corresponding angles. You recognize corresponding angles with the hint that I gave you if you can form an F with it. but you cannot say the F postulate. No one in geometry will know what that means. Thank you, sir. Thank you for your honesty. Any other questions, gentlemen? All right. Thank you very much. Hope you learned a lot. Have a wonderful day. It's the last lesson of the quarter.